If you've taken calculus before in the last semester or so, you probably have seen this. So I don't want to spend too much time on this. I hope you do take a look at it. On the left-hand side, general approaches to solving problems, and you'll have problems that you might need to know about. So a couple of things. Make sure you understand the problem before you jump in. I see a lot of people be like, I see the word plane. I'm not even going to bother reading the rest of the problem. I just see the word plane and a bunch of numbers. I'm going to do stuff. Like, no. Actually make sure you know what the problem is asking you to do. Understand how to solve the problem, which means, that's the second thing. Develop a plan and think about how to solve it. You do have time to think. This is why you only have 6 problems. We don't expect you to be writing the whole 90 minutes. We expect you to be spending at least 5 of those minutes thinking about stuff. Like, what do I do? What problem does this remind me of? What should I do to go forward? Make sure when you carry out the plan, in other words, do the problem, check each step and be clean. Be clean. Why? Because as graders, we like looking at clean answers. But it's not just for us. It's for you. Because you might want to check your answers. As they say, it's best to check yourself before you wreck yourself. So, check your work. Now, if you're going to check your work, you have to be organized. Because otherwise, you look at a page and like, what did I do here? And the graders have the same reaction. What did you do there? And so it's good to be organized. All right, anyways, I won't go and read through the rest other than to say the most important thing on the right-hand side is to remember the very last part here. No matter what happens, your instructors still care. We really want you to succeed. This is not like a, how can we flunk even more calculus students this semester than last semester? That's never our goal. We really want you to succeed, and we want you to have a positive experience. And I know that's strange to say before going into a test, but that's how we feel. Okay, so what am I going to do? I'm going to go through from the last year's exam. So there's 2 exams to draw from. We're not going to do the problem about quadratic surfaces. It's just because of this particular exam. You might get the feeling like, hey, all I have to do is watch this video or watch this lecture, and I'm set. Don't think that. I would say that if you can do all the problems that we talk about, you will get a pretty decent score. I would say you probably are going to be above average if you can do everything that we talk about today. But if you really want to do the very best, you want that sticker of excellence, you got to go a little bit further. What's that little bit? Make sure you can do those quiz problems. There's at least one problem on the test that people are going to be like, oh, this is like that quiz problem. How did we do that one again? So check the quiz problems too. And if you've been preparing properly, it should be pretty quick to check those. All right. And away we go. 10 problems, 50 minutes, 5 minutes per problem. All right, find an equation for the plane passing through the points 1, 3, 8, -2, -4, 7, and 5, -1, -4. That's part A. I'll do part A before I even attempt part B. So I'm given 3 points. Now, whenever I see the word plane, I say to myself, okay, I need a point and a normal. So that's always my thought process when I see the word plane. Point and normal will somehow be involved. Now, the good news is I have plenty of points, so I'm not worried about that. Bad news is I don't have a normal. Now, visually, you can say, I have 3 points. Here they are. And they might say, wow, how did you draw that so quickly? Because I didn't actually care if they were right. Intuition is more important than exactness. So I say, okay, I have my 3 points. And I say, well, I need a normal. And now how do you find normals? The best way to find normals is to not find the normal, but rather focus on what's perpendicular to the normal. Now, by definition, the normal is perpendicular to vectors in the plane. So I'm just going to make two vectors in the plane. And I'm going to use the points to do it. So I'm going to find the points between A and B, the vectors between A and B and between A and C. Does it have to be between A and B? No. Just pick two vectors. That's all I need. So, vector from A to B. What's that? All right. So, I just say, what's the difference? I went down by 3. Here I went down by 7. Wow, that's really down. And here I went down by 1. Wow, okay. Well, that's fine. It's okay to keep going down. A and C, well, what happens there? I went from 1 to 5, so that's up by 4. 3 to negative 1, that's down by 4. 8 to negative 4, that's down by 12. There are my two vectors. Okay, so how do I find my normal? Once you have two vectors which are perpendicular to your normal, you cross them. So AB cross AC. So I, J, K, negative 3, negative 7, negative 1, 4, negative 12. And we say, all right, what is that? Well, math. I times negative 7 times negative 12, that's 84I. Negative 1 times 4 times j is minus 4j. K times negative 3 times negative 4 is 12k. Go in the other direction. 4, negative 7k, that's negative 28k, but because it's the other direction, I'm going to actually add 28k. Negative 4, negative 1, I. But again, other direction, so I'm actually going to add, it's 4i, but it's going to subtract 4i. Whoops, I almost added it. Okay, negative 12, negative 3j, 36, subtract. And what do we get? Well, we get 80, negative 40, and 40. Now, we might be a little bit paranoid because I think I almost made a mistake. Well, check yourself. Quick dot product. 320 plus 160, 480, minus 480. Woohoo! Good, works. Now, the normal vector is a little bit misleading when we use the word the normal vector because it's not the, it's a. Really, we care about normal direction. And we use vector as a stand-in for direction. We say, hey, instead of 80, negative 40, 40, I can pull out any multiple they have in common. So 40, 2, negative 1, 1. So that 2, negative 1, 1, that's probably the vector to pick when I'm figuring out my normal. Okay, so here we go. Answer to part A. I have 2, negative 1, 1. So 2x minus y plus z equals something. Okay, where does the something come from? The answer is that the something comes from the point. So coefficients come from the normal vector. The something comes from, you pick a point, any point, and you say, all right, 2 minus 3 plus 8 is 7. Done. Done. Now, what if we were, again, very paranoid people? Well, that's a tough life to live. But we can even check this answer. Because it says, look, find the plane that contains these points. I checked A, plug in B. Minus 4 plus 7 is 7. Plug in C, 10 plus 1 minus 4, 7. It has to be the right answer. So good. I know I'm going to get full points on this problem. Oh, wait. No, only on part A. There's a part B. Ugh. Part B, how am I going to finish part B in this little space? Well, let's read the part B. Find the area of the triangle. So it says, hey, there's this triangle here with A, B, and C. What's this area? Now, how are we going to do it? Well, we key in on this word area. When you see the word area, there's only one thing we've done that involves area so far. Do you remember what it is? It's magnitude of cross products from parallelograms. So when you see area, you're probably like, hey, there's probably a cross product involved. So, in particular, what do we mean? Well, the cross product, if you take the magnitude, that's the area of a parallelogram. A triangle is half of that. So, I say, I happen to have the cross product. Already found it for part A. So the area will be half of that, because I want a triangle, not a parallelogram, of the magnitude. And now I need the whole cross product, 40 included. 40 to negative 1, 1. I can still pull out the 40. Half times 40 is 20. Then I square these. 4 plus 1 plus 1, giving me an answer of 20 square root of 6. And now I am done. All right. One problem down. I have to start speeding up.
So on A there, why didn't you go?
I have to speed up.
Okay, all right.
All right. Find the point on the curve. R of t equals 4 sine t I plus 4 cosine t j plus 3 t k that lies a distance of 5 pi units along the curve from the point 0.46 pi in the direction of increasing arc length. That's a lot of words. Okay. First off, you might not like this. I, j, k. If you don't like I, j, k form, rewrite into component form. 4 sine t, 4 cosine t, 3t. Same thing. Vice versa. Don't like this form? Write it in that. It's just different ways to write it. Okay, it lies a distance of 5 pi units. Now, a distance of 5 pi units is just another way of saying you've gone a length. This is arc length. This is an arc length problem. And we've gone from the point 0.46 pi in the direction of increasing arc length. Now, of course, here it's a little bit questionable about what increasing means, but that's okay. We'll wave our hands and say it means this. Now, we need to figure out t. So I'm starting at a particular point. So that says that 4 sine t is 0. Well, that could be a lot of things. 4 cosine t is 4. That could be a lot of things. 3t is 6 pi. Wait a second, that can't be a lot of things. So if I'm at the point where 3t equals 6 pi, what needs to be true about t? 2 pi. So I'm starting at time 2 pi. I move along this curve until I've gone a distance of 5 pi. Where am I? Well, you know, it would help to know what time I'm at. Because if I want to know where I'm at, I just plug in the right time. So here's the idea. I need to find my time where I've gone a distance of 5 pi. So let's call our time capital T. So I'm after capital T where the following is true. This is about cumulative arc length. Namely, that starting at 2 pi, because I want to start at this point, go to time capital T of magnitude of r prime of t. We'll clean that up in a second. So this is finding my distance is equal to 5 pi. Now, what is r prime of t? Well, it would be 4 cosine t minus 4 sine t, 3. So this becomes integral 2 pi to capital T square root 16 cosine squared plus 16 sine squared plus 9, because I square the entries of r prime. 16 cosine squared plus 16 sine squared? 16. 16 plus 9? 25. Square root of 25? 5. That's a constant. Pull out. 5 integral 2 pi to capital T dt. Well, that's easy. That's just 5 little t evaluated from 2 pi to capital T, which is 5 capital T minus 10 pi. Well, now, remember, this all equals 5 pi, because that's where we started. This equals 5 pi, remember? Move this across. 5 capital T is 15 pi. So, what's true about capital T? It's 3 pi. Yes, 3 pi. Good. Now, is the 3 pi the answer? No, because we read the problem. And it said, don't find the time. It said, find the point. So make sure you read the problem and actually give the answer for what it's looking for. So how do we find the point? Plug 3 pi in. So we plug 3 pi not to the derivative, original function. So our point, written in vector format, which is fine, we'll take that. 4 sine 3 pi, 4 cosine 3 pi, 9 pi. Well, sine of 3 pi, 0. Cosine 3 pi, negative 1. 9 pi, 9 pi. And we're done. All right, good. Almost back on track. Find the osculating plane to the curve r of t at time t equals 0. Now, recall that the osculating plane contains some information. Namely, it contains the point, the direction of velocity, and the direction of acceleration. So the osculating plane has these three things built into it. Well, that's good information. So I see the word plane. Even if I know it's a Valentine's Day thing and I know it's osculating means to kiss, I ignore that fact. Plane, I think point direction. Point direction. Okay, what's the point? I have the point because it tells me it contains the point on the curve. Well, and I'm at time t equals 0. That's going to be key because I need that time. So my point, we'll go ahead and nail that down now. R of 0. Plug in 0. Okay, 0 plus 2 plus 0. Well, 0 plus 2 plus 0. Whoops. It's going to write too quick. That'll become 2. 1 plus 0. All right, 1 plus 0. J. And 0 plus 1. Okay. All right. So 2, 1, 1. There we go. 2, 1, 1. That's my point. Good. Now, direction. I need the normal. Well, I know the plane has to contain, see, the plane contains a direction of velocity and direction of acceleration. So it's basically telling me I need the velocity and acceleration. So r prime. I prefer component form, but that's okay. Derivative of tangent, secant squared. Derivative of 2, 0. Derivative of t cubed, 3t squared, comma. Derivative of 1 plus t squared, 2t. 2t or not 2t? No, it is 2t. Sine t plus cosine t. Cosine t minus sine t. Good. Now, the plane will contain r prime 0. So this is motion. All right, or if you like, velocity. So plug in 0. All right, 1 plus 0, 1. 2 times 0, 0. 1 minus 0, 1. Okay, r double prime. Okay, derivative of secant squared t. That's right, it's 2 secant squared tangent. Good. Plus derivative of 3t squared?
6t.
6t. Derivative of 2t? 2. Derivative of cosine t minus sine t?
Minus cosine t minus sine t.
Yep. All right, minus sine t minus cosine t. Good. Now, plug in 0. R double prime of 0 is? 0, comma, 2, comma, negative 1. Now, this is acceleration. Okay, let's test our knowledge. Which one's the normal vector? Is it motion or acceleration? The answer is neither is correct. Good. Because these are in the plane. Now, how do I know? Because it tells me that the plane contains these directions. Now I have two directions in my plane. How do I find my normal? Cross them. You should get really comfortable with doing cross products. You might be doing more than one. It's very rare for us not to have you do a couple. All right, so we take our cross product, I, j, k, 1, 0, 1, 0, 2, negative 1. Well, they gave us nice numbers to work with because they love us. They love us. They want us to succeed. And so they're going to give us nice things to work with. All right, so anyways, as we go through here, if we do this quickly, it looks like we get minus 2, 1, 2. But of course, if we do it quickly, what should we do to be careful? Check it. Okay. Minus 2, 0, plus 2, 0. 0 plus 2 minus 2, 0. Good. Even if I did the cross product wrong, at least it's the right direction, so I'm good to go with the next part, which is to say I've got the point, and yes, I know that's the vector I'm pointing at, but it's a vector that represents the point, and I've got the direction, therefore I have the plane. These are my coefficients. So minus 2x plus y plus 2z, okay, equals something. So now, where's the something going to come from? And the answer is, it comes from the point. Minus 4 plus 1 plus 2. Negative 1. Yes? Good. Done. All right. Whoop. Went too slow on that one. Okay. Position function of a spaceship is given by the following. R of t is 3 plus t, t squared minus 7, t squared plus 2t. At time t equals 0 in seconds, you have to do some fast action here because you can see this happens in seconds. So we might take minutes to answer this. the ship's captain receives orders to turn off the ship's engines within the next 6 seconds. We might take more than 6 seconds to answer this. But that's why they're the captain, because they're fast. And then have the ship coast to a space station located at a point, 8926. Determine the time t when the engines should be turned off. And give the location of the ship at that moment in time. Woo, okay, what's happening? All right, so what's happening is you have to imagine that there's a spaceship here. Okay, so there's a spaceship here, and right now its engines are on. Okay, good. So it's traveling through space. You don't have to bring colored pens, by the way, on the test. All right, so the ship is traveling. Now, as a consequence, it's not going in a straight line. It's following some curved path. So this is r of t. On the other hand, over here, there's some orbiting spaceship. I don't know, it looks like a donut apparently. But okay, that's the spaceship. We'll call that the spaceship. And it wants to get to that spaceship. Now, what happens is it turns the engines off. What happens to that rocket once you turn the engine off? Goes along a straight line, a tangent line. So we want to make sure we find that magic spot, that tangent line which hits the space station. That's what we're after. Okay, now that we understand what the problem is asking us for, we say, aha, I just have to figure out what do tangent lines look like. And I want a tangent line which has that point. And that's what I'm after. That's what I'm after. Okay, so let's figure out our tangent lines. If I need a tangent line, I need a line. When I think of line, what information do I need?
Point and direction.
Point and direction. Good. So point is going to come from here. 3 plus t, t squared minus 7, t squared plus 2t. Direction, r prime. Derivative, which is 1, 2t, 2t plus 2. Okay, I've got my point, got my direction, but how do I make my line? Well, remember it's a point plus a multiple of direction. Now here's where you have to be careful. So I'm already using t. I'm going to leave t as t. So I'm going to say that my line looks like the following. The point, 3 plus t, t squared minus 7, t squared plus 2t, plus some multiple, I'm going to use s. 1, 2t, 2t plus 2. Why s? Well, because I don't want to confuse myself. I don't want t to be used twice. If I use t twice, I'm in trouble because the two t's represent different things. All right, this is my line for any given value of t. So once I plug a t in, I have a line. My goal is to find the right t. What's the right t? Well, the right t has to be this case that I can get to 8, 9, 26. So the question is, for which t can I find that? Do I care about s? No. I care about t, because t is time. I'm looking for a time. Now, how do I know I'm looking for a time?
It tells you.
Because it says to look for a time. See, that's the key. What does the problem say? That's what you should do. That's a pro tip, by the way. You know, you want to be a professional? Whatever it asks you to do that. Okay, all right. Now we're getting sidetracked. What do we have? We have 3 equations. Oh, this is going to be good. We love 3 equations. What do we know? Look at the x-coordinate. 3 plus t plus s, because 3 plus t plus s has to equal 8. Well, that's cool. That gives me a nice relationship between s and t. Let's go to the next equation. T squared minus 7 plus 2 times s times t should equal 9. Now, let's actually use just these two, and let's see what we can conclude. All right. So I really want to solve for t. So to do that, I'm going to take the first equation and actually get s. So move the 3 plus t across. S is 5 minus t. Now, plug that into here. T squared minus 7 plus 2 times 5 minus t times t equals 9. We expand. T squared minus 7 plus 10 t minus 2t squared equals 9. So far, so good? Now comes the fun part. We move stuff around. We're going to move everything to the right-hand side. And if we do that, we'll get 0 is equal to, here I have minus t squared goes across as positive t squared. Here I have 10t goes across negative 10t. Here I have negative 7. There's 9 already, 16. Now, does t squared minus 10t plus 16 factor?
Yes.
Yes. As how?
T minus 2 and T minus 8.
T minus 2, T minus 8. So, we get two candidates for t. What are our two choices, possible values for t?
2 and 8.
2 and 8. But we're told something. Notice that there was something that was bolded, underlined, almost as if it was important for your answer. Because it's important for your answer. It has to be within the next 6 seconds. I start at time 0. Which one can it be?
2.
Yeah, it can only be 2. 8 is not within the next 6 seconds. Now, if you were really careful about this problem, you would also check the third coordinate as well. But it turns out it has to be 2. It's the only possibility, and 2 is the correct answer. You know, I have to say, on this particular problem, the students did not like it last semester. They're like, it's not fair. You never showed us anything. But we did. It's like quiz problems. We did quiz problems like this. Good times. All right, I am really far behind. Go up. Speed faster. Okay, here we go. Sphere A has a line segment joining 0, 2, 3, and negative 4, negative 2, 3 as a diameter. So I have 0, 2, 3, and negative 4, negative 2, 3 as a diameter. Which means that if I look at this line segment, they're exactly opposite each other on this sphere. Now, I also have a second sphere, and it happens to have points 5, negative 2, 6, and 1, 0, 4 as a diameter. Okay, that means, again, they're exactly opposite each other. Now, what do we want? Give the parametric form for the line passing through the centers of both spheres. Okay, so we're looking for a line. Why? How do we know that? Because it says the line. Okay, give the line. Now, you'll notice I drew a picture. Pictures can help. So I'm looking for a line. How do you find a line? Pointing direction. Now, okay, so I have these two spheres. I have to pass through the centers of these two spheres. How can I find the centers? The midpoints. So this question is testing us on a couple of things. It's saying, hey, the midpoints. It's reminding us that a diameter means exactly opposite. It's like North Pole, South Pole. If I want the center, go halfway in between. So midpoints. Okay, so to find the midpoints, you add and then divide by 2. So 5 plus 1 divided by 2 says that this midpoint would be 3, negative 2 and 0, average would be negative 1, 4 and 6, average is 5. So 3, negative 1, 5 is that midpoint. Over here, what do we have? Well, average, 0, negative 4, would be negative 2, 2, negative 2, halfway in between is 0, 3 and 3, and halfway in between that is 0. Negative 2 is 0, 0. All right, I now have 2 points.
3, not 0.
Sorry, what?
It'd be 6 divided by 2, so it'd be 3.
Oh, you're right. 6 divided by 2. My apologies. Thank you. Ah, that's all right. I don't need the sticker. I can buy my own. That's right. Once you become a college professor, you too can afford to buy stickers. Not much else, but okay. You know, stay with the engineering major. It's good money. All right. So we need the line that passes through these 2 points. Okay, well that's fantastic. Now I have 2 points. I don't need 2 points. I just need 1 for a line. But there's a second thing I need, which is what? I need a vector, a direction vector. So I pick a direction vector. Now you might say, well, which one? Because I could go from this center to that center. I could go from that center to that center. And the answer is? It doesn't matter. Either one works. Okay, so I don't know. I like being positive in the first entry, so I'll go negative 2 up to 3 says, so I'm going this direction here. So that went up by 5. 0 to negative 1, I went down by minus 1. 3 to 5, I went up by 2. So now my line becomes x equals y equals equals. The first slot here, I pick a point. Either point doesn't matter. Lines are not unique. So you just pick whichever point you like. So I'm picking the negative 2, 0, 3. Plus, and now you pick multiples of the vector, plus 5t, minus t, plus 2t. And done. Finished. 10 points. And just to think, that problem is worth as much as this problem. Okay, Wow. Amazing. Amazing. Okay, we got to get the points on each one. All right. Consider the following two intersecting lines. Oh, this is sweet. It's like they've given us a bonus information. We know they intersect. R of t, S of u. Now, why did they pick u? Side note. Why did they pick u? The reason they picked u is to say, hey, be careful. The parameter I use for the first line is not the same as I use for the second line. So I switch. That's why there's two different variables. It's to our advantage. And we really want to have two separate variables. Now, part A. Find the coordinates of their point of intersection. Okay, so that's good. I need to find where the lines intersect. So if you think about what you have, let's write these in parametric form. So this one says x is 4 plus 2t, y is 2 plus 0t, and then z is 3 plus 3t. Now, on the other hand, I come over here. I get x is minus 1 plus u. I get y is 3 minus u. And I get z is negative 4 plus u. So now I have three equations and two unknowns, but hold on. Check out that middle one. It's calling to us and saying, pick me, pick me. Why? Because it only has a single variable. It's really easy to solve. What can I conclude? U equals 1. Sweet. Now, what do I do next? I don't panic. I just throw u equals 1 into there. What's the point going to be? Well, negative 1 plus 1. 0. 3 plus negative 1. 2. Negative 4 plus 1. Negative 3. Done. That's part A. Finished. Now you might say, oh, wait a second there. You didn't solve for t. I don't have to solve for t. Why? Because I know they intersect. I just have to find with point of intersection on a single line, which means I only have to find either t or u. How do I know they intersect? Because they tell us. That's how I know they intersect. All right. Well, that was great. Let's hope part B is just as fast. Find an equation for the plane containing both lines. All right. Now, it turns out you can get part B without doing part A. That's okay. We'll pretend like we needed part A. Let's talk about B. If I need a plane, I need a point and a normal vector. Well, I need a point that's on the plane. Do I know a point? Yes. In fact, I have infinitely many. This point works, but so does any point on either of these lines. They all work. So we have more points than we can possibly need. What else do I need? Normal vector. Now, so we start thinking, all right, where do I find a normal vector? Well, we think of the picture. So I have this line R, and I have this line S. We found the point of intersection. So now we're after the plane that contains both of them. So we start thinking, well, what's some directions in the plane? Because if we can find directions in the plane, we can use them to find the direction perpendicular. So what are some directions that have to be in the plane? 2, 0, 3 and 1, negative 1, 1. The directions of the line are in the plane because the plane will contain the lines. Therefore, I have two directions. 2, 0, 3, 1, negative 1, 1, and now we cross. Okay, and hopefully by now you're getting to the point where you're like, hey, I can do cross products. I can even do it while I'm casually talking about how easy it is to do cross products. Because, you know, after you do a few hundred of these, they get pretty simple. There's no real big surprises, but what do you always do after you do any cross product?
Check it.
Yeah, you check it. How do you check? Dot product. Okay, so 6, 0, minus 6, that's 0. 3, minus 1, minus 2, that's 0. There we go. Now, that's not our answer because that's not a plane. Remember, you have to know what the plane is. So we say these are our coefficients. 3x plus y minus 2z equals something. Now I'll use the point. I'll use the point for part A just to make them feel good. All right, 0 plus 2 minus 6. Grand total is? Oh, plus 6, yeah. So 0 plus 2 plus 6, grand total is 8. Okay, good. All right. Oh, it's gonna go faster. Find a sub t and a sub n, the tangential and normal components of acceleration for the curve r of t is cosine t plus t sine t I plus sine t minus t cosine t j plus 2k. Simplify your answer as much as possible. Now, the fact that it says simplify your answer as much as possible says there's probably a simple answer. So if you ever see the phrase simplify as much as possible, you should be very, very suspicious if it's not looking simple. It should be like, wow, this is really simple. And if it's not, you should be, I think I made a mistake. Now, so you go through and you take derivatives. Now, nothing's very surprising. I'm going to switch to component form just because I like component form. Now, these are not just randomly chosen functions. If you go through and take the derivatives here, you'll get the following: t cosine t, t sine t, and 0. All right. And then our double prime of t, it's easy to see that you get 0 because derivative of 2 is 0. It's not really even a fair question because it's just a curve in the plane, really. Our double prime, this becomes cosine t minus t sine t, then sine t plus t cosine t, and it's still 0. Now there's two ways to go. You can do geometric, which is r prime dot r double prime over the magnitude of r prime for the a sub t, magnitude of r prime cross r double prime all over the magnitude of r prime for a sub n. But in the interest of speed and time, we're going to do it algebraically. So magnitude of r prime, square root of t squared cosine squared t plus t squared sine squared t plus 0 squared simplifies to t. We'll just assume positive t, don't worry. All right, the derivative of the magnitude of r prime is 1. This is a sub t. Halfway done. All right, for the second half, we're going to find the magnitude of r double prime, because we'll need that. Actually, we can find the magnitude squared. That's what we need. So we take cosine t minus t sine t squared plus sine t plus t cosine t squared plus 0 squared, which is cosine squared t. By the way, if you do these a lot, and say for example about the 5th or 6th time you've taught multivariable calculus, you'll start to see that there's almost always a pattern when you see sines and cosines. When you square them out, you get a lot of sine squareds and cosine squareds, which add together. But the other thing which tends to happen, and you sort of should keep your eye out for, is be like, hey, these middle terms cancel out. So what's left? Well, you get cosine squared plus sine squared, which is why I look for those cosine squared plus sine squares. T squared sine squared plus t squared cosine squared, t squared. Now why do we do that? Well, because we know that a sub n squared is equal to the magnitude of acceleration squared minus a sub t squared. Well, that's 1 plus t squared minus 1, which is t squared. So what is a sub n? T. All right. And we're done. Okay, cool. When a curve intersects a plane, the angle of intersection is the angle between the normal vector to the plane and the tangent vector to the curve at the point of intersection. Find cosine theta, where theta is the angle of intersection between the curve r of t is log t, 2, 3t squared, and the plane 3x minus y plus 2z equals 4 at the point 0, 2, 3. Now, I see cosine theta. When I see cosine theta, what do I think of? Dot product. So cosine theta is u dot v over magnitude of u, magnitude of v. I just have to figure out what my vectors are. But it's telling me what my vectors are because it wants me to know things. It wants me to know things. It says, hey, what are the vectors? Well, it's the angle between the normal vector to the plane. Okay, so what's the normal vector to the plane? What? 3, negative 1, 2. Cool, we're halfway done. And the tangent vector to the curve at the point of intersection. Well, let's look at this curve. It's log t, 2, 3t squared. Now, the point of intersection is at 0, 2, 3. So, what value of t am I at the point 0, 2, 3? Yeah, 1. Because 1 is the solution. Now, I say, wait, what about negative 1? No, I can't take log of negative 1. So, we know the intersection happens at t equals negative 1. Good. Sorry, positive 1. I'm sorry. I'm thinking too hard. All right. Now, that's when it happens. To find the angle of the curve, to find the tangent vector, take the derivative, which is 1 over t, 0, and 6t. Now what? Plug in 1, because that's when it happens. 1, 0, 6. So that says our second vector is 1, 0, 6. So now we found the two vectors. Why did I write u twice? U is the vector so nice, I wrote it twice. Okay, v. U and v. So we're ready to go. Cosine theta is u dot v over magnitude of u, magnitude of v. All right, so this is a problem that gets to test our dot product skills. It's good to know both dot product and cross product. So upstairs we're going to get 3 plus 0 plus 12. Downstairs we're going to get the square root of 9 plus 1 plus 4 times the square root of 1 plus 0 plus 36, which we can do a little bit. We can say that's really 15 over the square root of 14, square root of 37. And at this point, what do you do? That's right. If it doesn't say you have to simplify, you don't have to simplify. Wow, that's really cool. Man, they like us. Yes, they do. They like you a lot. All right. A particle has acceleration given by t plus 1, comma, e to the t, comma, 3t squared. At time t equals 1, the particle has velocity 5/2, 0, 1. And at time t equals 0, the particle is at position negative 2, 4, 0. Find the position of the particle at t equals 2. Okay, well, so what do we need? We need to find position. We got to work our way up. We have acceleration. So we have, okay, I'm going to write it again, t plus 1, e to the t, 3t squared. So how do I go from acceleration, get to position? I integrate. But if I integrate once, integral of acceleration becomes velocity. Well, what is that? Well, 1/2 t squared plus t plus c, comma, e to the t plus d. Now we want to be careful because we don't want to use the same letter because that will confuse us. It's a different constant, comma, t cubed plus e. Good. Now, what do we say? Well, we know some information. At t equals 1, the particle has velocity 5/2, 0, 1. So in other words, plug in 1 into velocity, you should get 5/2, comma, 0, comma, 1. That's that piece of information. Translate it into Mathanese. Got to translate into that common language of math. Now, that's going to be equal to, plug in 1, 1/2 plus 1 is 3/2 plus c. Here, I'll get e to the, what time is it? Time 1. I'll get e to the 1 plus d, and then here I'll get 1 plus e. Yes? Good. Now we say, what happens? Well, what does that tell us? 5/2 equals 3/2 plus c. C is 1. 0 is e plus d. D is negative e. 1 equals 1 plus e. E is 0. So, updating. Velocity is 1/2 t squared plus t plus 1, comma, e to the t minus e, comma, t cubed. All right. Now, r of t. Well, now we go next step. Integrate again. Integral of 1/2 t squared plus t plus 1. 6t cubed plus 1/2 t squared plus t. Integral of e to the t minus e. It's e to the t minus e times t. Be careful. The integral of e is not e to the t. It's e times t. E is a constant. Oh my God. Oh wait, no! I screwed it up. I screwed up. What did I forget? Plus another variable, constant, right? We're working our way through the alphabet. We already used C, so we're up to F. Thankfully, we don't start with this, the 17th root, otherwise we'd have to create new letters. plus g. And the last slot, 1/4 t to the 4th plus h. Now, plug in 0. At 0, I know the position of the particle. So, -2 for 0 is the position at time 0. So I plug in 0. And let's say I get 0 plus 0 plus 0 plus f. Then I get 1 minus 0 plus g. So 1 plus g. Then I get 0 plus h. So let's talk about these. What do we know about f? -2. What do I know about g? 3. What do I know about h? 0. So I can really update on the bottom here and say that r of t is equal to 1/6 t cubed plus 1/2 t squared plus t minus 2, comma, e to the t minus e times t plus 3, comma, 1/4 t to the 4th. So that is my position. I need to find the position of the particle at time t equals 2. So what do I do to finish it up? I plug in 2. Okay. So my answer, plug in 2. I get 1/6 times 8, which is 4/3. 1/2 times 4, 2, plus 2, minus 2. Actually, that cancels out, so I'll just leave it as that. E squared minus 2e plus 3. And 1/4 times 2 to the 4th. 1/4 times 16, that's 4. I could do something. I could say 4/3 plus 2 is actually 10/3, which is fine. Or I could leave it as 4/3 plus 2. But I don't mind a little bit of arithmetic in the morning. It's a good way to wake up. All right, good. That's done. All right, not done yet though. More to come. More to come. Okay. A particle's motion is given by r of t is e to the t cosine t, e to the t sine t. Find the distance the particle travels between the points 1, 1, 0 and e to the pi halves, 0, e to the pi halves. Now, first off, it says between the points. We don't want the points. What do we really want to have? The time. The time. Okay, so remember, these look like e to the t cosine t, e to the t sine t. Now, I can look in any entry, but it's usually best to look where there's very few t's. So I'm going to look in the first entry. When am I going to have e to the t be 1? 0. When am I going to have e to the t be e to the pi halves? Pi halves. So secretly, this was just telling us, hey, can you figure out when you're at a certain point? And that's good to be able to do. So we're actually going to have time is going to go between 0 and pi halves. So that's what we really know. Now, a distance, we say, whenever I see something like that, I say, this is arc length. So we have an arc length problem. Time goes between 0 and pi halves. What's the next thing I need to do to keep going on this problem? R prime. So r prime of t is, derivative of e to the t is e to the t. Derivative of e to the t cosine t. Get to flex our product rule formulas. You know, it's good to remember those. Let's see, it's e to the t cosine t minus e to the t sine t, comma, and then it's e to the t sine t plus e to the t cosine t. Okay, so there's our r prime. What comes next? Magnitude. Magnitude of r prime, which is the square root of, we square it. Now, got to be careful here. E to the t quantity squared. I'll write as e to the t squared for now. E to the t cosine t minus e to the t sine t squared plus e to the t sine t plus e to the t cosine t squared. Of course, I feel silly after having done this because I could have made my life so much simpler, but that's all right. We don't need to live a simple life. We're engineers in here. We like complex things. Now, what could have been simpler? Well, everything has e to the t in it. Pull it out at the start. And instead, I'll just pull it out now. Look, everything has e to the t. Everything, pull out all those e to the t's, take that out of the square root, you get e to the t. Square root of. Now, because I pulled out e to the t, I get 1. And here it's going to be cosine t minus sine t squared. So that's going to be cosine squared minus 2 cosine sine plus sine squared. Then I'm going to get, again, I pulled out the e to the t, sine plus cosine squared. Sine squared plus 2 sine times cosine plus cosine squared. Okay. If we do this right, we should anticipate, whenever we see things like sines and cosines like this, what do we anticipate? Cancellation for the middle terms, and then lots of 1s. Cosine squared plus sine squared plus cosine squared. So how many 1s do I actually have in here? 3. 1, 2, 3. Okay, so it's square root of 3 e to the t. Wow! Beautiful. It's like it should simplify to something nice, because it should simplify to something nice. Now, this is a case when the magnitude simplified to a very clean formula. As a general rule, look for magnitudes when you're looking for arc length. Look for things to factor, things to simplify nicely, ways to deal with the square roots, because we'll give you ways to deal with any square roots that you encounter, because we want to see numbers. We like numbers. Now, we're not done, but we know how to finish it. So the answer is going to be 0 to pi halves. That's our time. Magnitude of r prime. Okay, I'll go ahead and write that down. 0 to pi halves, square root of 3 e to the t dt. Integral of square root of 3 e to the t. Square root of 3 e to the t. Go from 0 to pi halves. So this becomes square root of 3 e to the pi halves minus e to the 0, which is 1. You can't simplify that. All right. And now, almost there, because that was the last problem. All right. And I still have 2 minutes left. I could have gone a lot slower. That gives me time to check all my work. Okay, so since I have 2 minutes left, back to slide 1. Be well rested, focus on ideas, be calm, relax. You've seen this before. Work on the ones you know first before getting stuck. And remember, what we've done today will get you most of the way there, but if you want to cross the line, you want to get all those points, got to get them all. Also study the quiz problems. If you can do everything today plus the quiz problems, you're good to go. And see you tomorrow.